And we will review, this is a review of the last things that we did on Thursday, where we learned how to solve what are called quadratic equations. And we know this is a quadratic equation, number one. It says solve, so, and it has an equal sign. So it's certainly an equation, and it's something that we want to solve. And in our equation, we have an x squared. So when we have an x squared, we know this is not a first degree equation, it's a second degree equation, it's an equation with an exponent in it. And the way we're going to do it is by factoring. Now, usually what I do is I look where and I have to get it all equal to 0. And when I look at it, I want to see where the x squared term is positive. Because it's much easier to factor if you're starting out with a positive x squared. It's not wrong to do it the other way, but since I see that my x squared is positive, in this case, on the right side, I'm going to take this negative 100x and bring it to that side. So I'm going to add 100x to both sides, so that I get the equation 0 equals x squared plus 100x. I have to, when I'm solving a quadratic equation, I want to get one side equal to 0. And then we look at the other side and we try and factor it. Now, if we can't factor it, it means that we have to go to a different method that we haven't learned yet. All the quadratic equations that we have learned how to solve so far are factoring ones. And if I look at this one, I only have 2 terms. In any case, the first type of factoring I always look for is a common factor. So I'm going to see if I have a common factor, and indeed I do, because there's an x that's a common factor. I'm going to leave this side alone. This will give me x and x plus 100 inside the parentheses, because I'm dividing both terms by x. And after I have factored it into 2 factors, I take each of those factors separately and set it equal to 0. So I'm breaking this up. There are 2 pieces. One piece is the x, so I'll set x equal to 0 as one answer. The other piece, the other factor, is what x plus 100, and I'll set that equal to 0. If in this case, I don't have to go any further because it gives me my answer is 0. In this case, I'm going to have to bring the 100 to the other side. I'm running out of room, so I'll just put it over here, which gives me x equals negative 100. And we got our 2 answers. Our 2 answers are 0 and negative 100. Doesn't matter which you write first and which you write second, but when you have a quadratic equation, you're looking to get 2 answers, and don't forget that since x was a common factor, that gave us, that was one of the things you had to set equal to 0. Any questions about that? Okay, so let's look at the second one. This one tells me that I have y times 3y plus 11 equals 4. Now, if I look at it, it looks like it's already factored. It's already equal, has a parentheses in it, except that's not a help, because when we are solving a quadratic equation by factoring, the other side has to be equal to 0. Now, if this would have been equal to 0, then I could have right away gone and set each one of these equal to 0. They would have been saving me time. But since this is equal to a number other than 0, it happens to be equal to 4, I have to remove the parentheses over here and work from there. I first have to distribute this y, which will give me y squared, 3y squared, I'm sorry, 3 times y times 3y is 3y squared, plus 11y equals 4. And now I do see that it's a quadratic equation because it has a y squared. So I'm going to have to get it equal to 0. So I'm going to bring this 4 to the other side so that my equation in standard form becomes 3y squared plus 11y minus 4 equals 0. So in this case, I had to first remove the parentheses and get it equal to 0. And now I'm going to proceed with solving this equation by factoring. And of course, we're going to do, since this is a trinomial, I'm going to use my AC method. So I look at it. The AC is the 3 times the negative 4, which comes out to be negative 12. And my B, the number in front of the Y term, is positive 11. And if we remember from our factoring, we're going to be looking for two numbers that are going to multiply to negative 12, but when I combine them, they're going to give me a positive 11. Now, if you think about it, since we mentioned this before, when the AC is negative, it means one of the numbers you're looking for is going to be a positive number, and one is going to be a negative number. And if the numbers that multiply to 12, well, it could be 12 and 1. As a matter of fact, if I look at it, that's the right combination because a positive 12 times a negative 1 will give me negative 12. And when I add positive 12 and negative 1, it gives me positive 11. So I'm going to rewrite this 3y squared, the 11y as plus 12y minus 1y and minus 4. So we've taken this single term and broken it up into two terms. So now we can do grouping. In my first group, I have a 3y that's a common factor. That is going to give me 3y times y plus 4. And my second group, and you don't have to put that one in, but if you put it in, it doesn't matter. You could have just written it as negative y. But your common factor, there's no common factor except the negative 1. You must put in a number in front of that. If you don't have any common factor, then just put a 1, but you must put a 1. And since this term is negative, my common factor is negative 1. And negative 1 into negative 1y is y. And negative 1 into negative 4 gives me positive 4. So that this is this factors to y plus 4 as my common binomial factor, and 3y minus 1. Now that I factored it, I'm almost finished here. Let's go over here. I now am going to take each of these factors and set them equal to 0. So I have y plus 4 equals 0, and 3y minus 1 equals 0. So I take each of the factors. Notice here we also took each of the factors, even though this wasn't in a parentheses, it didn't need to be in a parentheses because it was just a single term, but it was a factor. You set each factor equal to 0. First we'll subtract 4 from both sides and we'll get y equals negative 4 as one answer. On the other one, we'll add 1 to both sides, which will give me 3y equaling 1. And now I'll have to divide by 3 to get the y alone. So my two answers come out to be negative 4 1/3. Sometimes you do get fractions, you certainly can get negative answers, but this is your solution. So that's where we had left off the last time we had met. We had completed all the factoring type of examples, and we had done the quadratic equations. We're going to do a little bit more of some things that apply to this chapter, but basically at this point we have completed the work that is going to be on the midterm. So let me just remind you, but starting this afternoon, you will be able to access on Blackboard, this is on Blackboard, not on Delta Math, on Blackboard, in the test section, you'll see there's a section that'll say tests and quizzes, whatever, a practice midterm. Now, this is actually the second test you're going to be taking this term. This is, I'm calling it a practice midterm as well, because it's very similar to the midterm in terms of all the material that's on it. It's on all the material from the beginning of the term, and also in terms of the style of which it will be given. The way that's why I want you to do this test specifically, because it's very important for you to have practice in doing tests on Blackboard. Again, it's going to be the mark will count as the second mark of the term. If you don't do well and you want to take it a second time, I will allow you to do that. Also, if you do better on the midterm than you do on this practice midterm, then I will count as the mark for this second test, also the mark that you got on the midterm. In other words, let's say on this test you get score 70, but on the actual midterm you score a 90. Instead of keeping your second test mark as 70, I will make the second test mark a 90 as well as your midterm. Whatever the midterm mark is, that's what you're going to get. There's not going to be any practice midterm. This is the practice midterm. There's not going to be any retakes of the midterm. The midterm is given by the department, but it will be set up similarly to the way this is given. I have set it up so that starting this afternoon, it will be available once you start the test. The same thing is in Delta Math. Once you start the test, you have to complete the test. You can't do 2 questions and then go away and come back, because if you close the test, it won't reopen. And the total amount of time I've given for this test is a total of 20 questions. I've given you 70 minutes, an hour and 10 minutes. Really, it's supposed to be an hour. I'm giving you a little extra 10 minutes because it takes a little bit of time to get used to it. Again, once the 70 minutes pass, the test closes and it's finished. So you have to make sure to be completed with the test in that one session in the time allotted. It is a multiple choice test. So you have to work out the examples, but you give the answer on you pick the correct answer. Again, you'll see it's pretty self-explanatory. So that's going to be available until next Tuesday. In other words, you could set aside yourself a time, an hour and 10 minutes, an hour 15 minutes, that you know you're not going to be bothered, and sit and do the test in one shot. Does anybody have any questions about that? The midterm is next week. I haven't heard from the department whether if it has to be an in-class midterm, if it has to be at the time that we usually have our class, it will be a week from Thursday. If not, if I have an option of letting you take it like I'm doing with a practice midterm, then I'll probably put it out someplace starting next Tuesday through Friday. So, but it'll be after, certainly starting after class next Tuesday, sometime between then and Friday, it's going to have to be done. And again, it's going to be 20 multiple choice questions. Is that clear, Ismail?
Yeah, that's clear. Thank you.
Good. Okay, so let's go on with, I just want to do a couple more things that have to do with multiplying, dividing, etc. Because the next chapter actually that we're going to be going into, which is chapter 5, is going to be a chapter where we're going to be working with fractions. And we're going to see that in that chapter, we're going to have to be doing factoring a lot as well. Let me just also mention that chapter 5, what we're doing now, is generally, it will not be on the midterm as far as I know. Maybe what we're doing right now would be, but as we go into chapter 5, which is really about fractions, that is really going to be included on the final. It's not part of the midterm. What I want to go back is we've been really working with polynomials in this chapter, adding, subtracting, multiplying, factoring. I just want to spend a little bit of time talking about monomials. In terms of how we multiply monomials, we mentioned it before, but and how to use exponents with monomials, and also how to, we talked about multiplying, we didn't so much talk about dividing, so let's talk about that. So let's say I gave you something that looks like this. 3x fifth times negative 10x seventh. I mean, everybody will remember, we actually did mention this, that when we're multiplying monomials, we multiply the numbers in front, the coefficients. The 3 times a negative 10 would give us negative 30. And then we multiply the letters by adding their exponents, and that would give me negative 30 x to the 12th power. What would happen if I had something like this, though? 3x to the 4th raised to the 3rd power. What if we have a monomial with an exponent on it? We talked about what would happen if we wanted to multiply to binomials and we use FOIL, etc. But what happens if we have an exponent on a monomial? We didn't really talk about this. And there really are, this one could be done in two different ways. Number one, we could just rewrite this as 3x to the fourth times 3x to the fourth times 3x to the fourth. When we have a cube, a 3 exponent on the outside, what it's telling us is that we're multiplying what's ever inside this parentheses 3 times. That's what the exponent is telling us. So if I want to do it that way, I'd have to do 3 times 3, which is 9, and 9 times 3, and that would give me 27. Don't forget, you have to do the 3 to the exponent as well. And in terms of the exponents, we have to remember when we're multiplying, we're adding the exponents. So 4 and 4 is 8 and 4 is 12. So my answer would turn out to be 27x to the 12. Don't forget, since this was a parentheses, both the 3 and the x to the fourth were to the third power. So that is certainly one way of doing it. That's fine because the exponent was 3. But what if my exponent was something other than 3? What if my exponent was 10? Then I'd have to write down something 10 times. So we'd like to see, is there a quicker way of going about this? How do we deal with exponents on top of exponents? So I'm going to do this in 2 steps. First of all, if I have something like x to the fourth, and I raise it to the 5th power. In other words, this means I want to do x to the fourth multiplied by itself 5 times. The easier way to do it is just to take the exponents and multiply them. When you have an expression with an exponent raised to a second exponent, you have 2 exponents on a number. The rule is you multiply the exponents. In other words, this would be x to the 20th. That's why when I had this x to the fourth to the third power, eventually I got x to the 12th power because 4 times 3 gave me 12. What happens if I have something like this? Suppose I had x to the fourth, y squared, raised to the 5th power. What if I have 2 terms in 2 factors here, x fourth and y squared, and they're both being raised, the whole expression x4, y squared is raised to the 5th power. So when you have a monomial which has a couple of letters or variables, what you're going to do is you're going to distribute this exponent on the outside to each of the factors on the inside. In other words, I'll first have to do x to the fourth to the 5th power. So I'll do 4 times 5, and that'll give me 20. So I'll get x to the 20. And then I have to do y squared to the 5th power. So I have to do 2 times 5, and that gives me 10. So my answer would be x to the 20, y to the 10th. This is called distributing the exponent on the outside to each of the letters on the inside. Well, what if we have something like this? 2x to the 7th to the 4th power. What if it's not just letters that I have? suppose I have an expression that also has a coefficient. Now remember what I did. I took each of the factors, each of the things that were being multiplied, and just put the fifth exponent to it. So I'm going to do the same thing over here. This 2 really is 2 to the first power. If there's no exponent on something, it's understood that its exponent is 1. So when I have 2x to the 7th to the 4th power, I have to put the 4th power to the 2 and get 2 to the 4th, and the 4th power to the 7, and 7 times 4 is 28, and that'll give me x to the 28th. Notice it's easier to deal with the letters, with the variables, than this with the numbers. Because here, even though I got 2 to the 4th, that's usually not the way you leave the answer. You have to figure out what 2 to the 4th is equal to. Now, either you could take out your calculator and use your exponent button, or you could just, this you could do in your head. 2 to the 4th means 2 times 2, which is 4. 4 times 2 is 8. 8 times 2 is 16. 2 to the 4th is 16, because if you multiply 2 4 times, you get 16. So your final answer in simplest form would be 16x to the 28th. So when we have an expression that has exponents and it's raised to another exponent, it's in a parentheses. Notice there's no plus or minuses in here. These are all monomials, but they have an exponent on the outside. You have to apply that exponent to everything inside. Here we had to do the x to the 4th to the 5th power to get the x to the 20, and the y to the 2 to the 5th power to get y to the 10. Here, when we had 2x to the 7th to the 4th power, we had to do 2 to the 4th power, which gave us a 16. And the x to the 7th to the 4th power, and the 7 times 4 gave us 28, so that gave us x to the 28th. Okay, let me give you one to try on your own, 1 or 2 to try on your own. Minus 5x 4th, y 5th to the 2nd power squared. Okay, I'm giving you a minute to try that one.
Professor, is that Y5?
Yes, y to the 5th. I'm gonna make it clearer. That better?
Yes, thank you.
Okay, let's try this together. Now I'm going to, I see there are 2 ways I could have done it. one way is just, the exponent is 2, so that's not so hard. I could have just done -5 x4 y5 times another -5 x4 y5. That's how we've always done it. When we're squaring something, we're multiplying it by itself. We write it twice, and we just now multiply it. And we'll see that we get -5 times -5, which is positive 25, because a negative times a negative is positive. X to the 4th times x to the 4th, the 4 and 4 gives me 8. Y5 and y5 gives me y10. And if you got this answer, this is completely correct. Just to show you that we could have done it the other way, the way with distributing the exponent that we learned just now. If we're going to do that, we're going to have to take this 2 exponent and put it on every single factor. One of the factors is -5, so we're going to have to do -5 to the square. I'm writing this whole thing out, but you could really do it in your head. The next factor is x4th. You're going to have to do that to the square. And the next factor is y5th, and you'd have to do that squared as well. Don't forget that you're squaring every single, as I said, factor, everything that's being met, which means the coefficient as well. When you square the -5, and remember, it's -5 that's being squared. -5 times -5 is 25. And here you just multiply those exponents. 4 times 2 is 8, 5 times 2 is 10. And of course, we come up with the exact same answer that we got before. Again, when you're just squaring, when your exponent on the outside is a 2, it's relatively easy just to write it and square it. When your exponent is more than 2, then you want to be able to use this more efficient method of distributing the exponent. Now, let's see what happens when we have a fraction. What happens if we have something that looks like this? -x to the 6th y cubed over x cubed y squared. What if I have a fraction with variables in it? If you recall, what we said we do in that case is we take each variable and we divide. First, we're going to divide the negative. This is like a -1 divided by a +1, so that's going to be negative. The x6 divided by the x cubed, remember when we're dividing, we subtract the exponents. We always subtract the top exponent minus the bottom exponent. 6 minus 3 is 2, so that gives me x to the 3rd. And y3 divided by y2, again, we do 3 minus 2 is 1, so that's y to the 1, or just plain y. And my answer then, in this case, becomes -x cubed y. Now, if you have something like this. Let's say we had an example that looks like this. We'll do a few examples and then I'll give you a couple to try on your own. Suppose I had 6x4 over 3x7. Now, what we want to end up with is as simple a fraction as we can get. Well, obviously, we see that the 6 and the 3 can cancel out. I can divide the top numerator and the denominator of the fraction by 3. That will give me 2 on the bottom, and the 3 is just a 1, or you don't have to put in that 1, but it really cancels out. The question is, what do we do with the x4th and the x7th? So according to what I told you before, what you're supposed to do is subtract the exponents, and you have to subtract 4 minus 7. And really then, if you did 4 minus 7, you would end up with a negative exponent. We really don't want to end up with answers with negative exponents. So what we do is we reduce the fraction. We're not dividing so much as reducing the fraction by canceling out the largest common factor. Now we know about common factors. If you have 2 letters, if they're the same letter, the greatest common factor is the one with the lower exponent. In other words, I can divide the top by the greatest common factor, which is x4th. That'll cancel this out. And when I divide the x7th by the x4th, it'll give me 7 minus 4, it'll give me x to the 3rd. Notice, I'm getting x to the 3rd, which you expect, but the x to the 3rd is in the denominator. In other words, your final answer comes out to be a 2 on the top, and you don't have to put on the 1, x to the 3rd in the denominator. Whenever you're reducing a fraction, you always want to cancel out the lower exponent, and your answer, after you subtract, is going to be in the position where the larger exponent was. The answer here is not 2x to the 3rd. The answer is here's 2 over x to the 3rd. Some more examples here. Okay. Now, just to go a step further. We have only used the type of exponents that are what we call whole numbers. Actually, exponents can be any type of numbers. They can be positive whole numbers. They can be negative whole numbers. They can even be fractions. So I'm not going to talk about fractional exponents right now, but what I do want to talk about is what happens if we have either a 0 exponent or if we have a negative exponent. What is the meaning of these type of exponents? So first of all, anytime you have something to the near 0 exponent, and it doesn't matter what it is, it could be x to the 0, it could be 15, a 5th, b 4th to the 0. Anything to the 0 exponent is equal to the number 1. Whenever something doesn't have an exponent written, it's understood that that exponent is 1. If there is it's not that the exponent is 0. If the exponent is 0, it's going to specifically say the exponent is 0. And if that exponent is 0, then you just get the plain number 1. It's not equal to, it doesn't have any variables, anything. It doesn't matter how complex it is. Anything to the 0 exponent is 1. Okay, so that takes care of the exponent when it's 0. What happens if you have something with a negative exponent? Let's say you have x to the negative 5. What does that mean? Well, really what it means is you have to take its reciprocal. Every single, I'm going to show you the easiest way to deal with this. This is, I mean, that when I say the easiest way, it sometimes takes a little bit more time, but it's a method that always will get you the right answer. Whenever you have an expression with exponents, especially if there's a negative exponent, and you want to simplify it, first of all, if your example is not a fraction, write it as a fraction. If it is already a fraction, then that's good. So we had this x to the negative 5th, and we're going to put it over 1 to make it into a fraction. Here's what you do with a negative exponent. A negative exponent indicates that you have to take the reciprocal. Taking the reciprocal means you're flipping it, which means if you're flipping something, you're putting whatever is in the numerator into the denominator. Whatever is in the denominator, you're putting into the numerator. That's what taking a reciprocal is. So when I see this x to the negative 5, I know that it means that I have to take this thing and put it in the denominator. It's in the numerator, flip it, switch it to the denominator, and make the exponent positive. Now, there's also this 1 that was in the denominator not before. X to the 5th times 1 is just going to be x to the 5th. But what are we left with in the numerator? Well, obviously, if nothing is left there, we can't just leave it blank. It means that it's 1. Again, it doesn't mean 0. It means 1, because we basically divided by my common factor. So when I get x to the negative 5, really what it means is 1 over x to the 5th. It means take the reciprocal. But again, the easy way to do it is write it as a fraction, and if it's in the numerator, put it in the denominator. Now, if you have something in a denominator that has a negative exponent, when you take its reciprocal, it's going to go from the denominator into the numerator. So if I have an example that looks like this, suppose I have this example. (36) x4 y7 over -4 x5 y -8. Again, I have a fraction that has a monomial in the numerator, a monomial in the denominators. Notice these are not polynomials, because there's the only operation in the top is really multiplication. So how do we simplify something like this? So my first step is, if I see that something has a negative exponent, I want to deal with that first. And what the negative exponent tells me is that I have to take its reciprocal. Now, nothing on top has a negative exponent. The only thing that has a negative exponent is the y to the -8 in the denominator. So I'm going to leave everything alone. 36x4 of y7 and the -4x5, except I have to deal with this y to the -8. Now, remember what I told you, what a negative exponent tells you to do. It's telling you to take the reciprocal. How do you take the reciprocal of something like that? It's in the denominator, so to take its reciprocal, I have to put it into the numerator and make the exponent positive. So when I see, so that's my first step. Look for any negative exponents. You want to only work with positive exponents. If you see a negative exponent, then take care of it. If it's in the numerator, bring it to the denominator. If it's in the denominator, bring it to the numerator. Of course, this then gives us, if we simplify this, 36x4, the y7th and the y8th, they're the same letter, we add their exponents because now we're multiplying it, gives me y to the 15th. And on the denominator, I have negative x, 4x to the 5th. Well, I still want to finish this up. I want to simplify the 36 and the negative 4. Well, negative 4 into 36 gives me negative 9, and this cancels out, happens to cancel out. And the x4th and the x5th, those are the same letters. I'm going to cancel out, cross out the one with the lower exponent, and subtract that exponent from the higher one. So 5 minus 4 is 1. So that'll give me x to the 1, or just x. And notice it's in the denominator because that's where the larger exponent was. So that my final answer in simplified form is negative 9 y to the 15th over x. This is your final answer. And you have to do this carefully, but step by step, because it's very easy to make mistakes when there's so many things going on and so many, and the exponents can be relatively large. But you want to first deal with your negative exponents, make sure that your exponents are first positive, and then you can deal with the whole expression. I'm going to do one more, and then I'm going to give you one to try. Okay. So I'm going to do one that's really quite difficult. Suppose I have 3x to the negative 4, y to the 8th to the 2nd power over 9 x4 y to the negative 3. What I did is I combined both types of examples. It gave you something that has an exponent on a parentheses, and I also gave you something with positive and negative exponents, etc. How do I go about dealing with something with so many things going on? So I like to do it in order. The first thing I do is I try to deal with the parentheses. That's what I've always done. I try to remove my parentheses. Now let's remember, if we want to remove the parentheses, that means we have to distribute this exponent on the outside to each of the factors on the inside. In other words, I'm going to have to do the 3 to the 2nd power, the x to the negative 4th to the 2nd power, which is going to be x to the negative 8. It's really pretty easy to do. And the y to the 8th to the 2nd power, which is going to give me y to the 16th. Actually, I shouldn't have even written this as 3 squared. I should have right away written this as 9, because 3 squared, I had a square. Don't forget, that coefficient is part of what has to be the exponent is on that coefficient as well. So it becomes 9x negative 8, y to the 16. If there had been an exponent in the denominator, I would have gotten rid of it also. So that gives me, let me just erase this. There's not, so we have 9 in the denominator, 9x fourth, y negative 3. So step number 1, if there is parentheses with an exponent on the outside, remember we're dealing only with monomials right now. If there's an exponent on the outside, it means distribute that exponent to every single factor, every number in front, every coefficient, and every letter. Okay, once you have no parentheses, then you can start simplifying by then doing the next step. Look if there are any negative exponents. First of all, if there's a 0 exponent, you can take that thing and right away make it into a 1, whatever it has a 0 exponent. Well, we don't have any 0 exponents, but I do see things that have negative exponents. So I'm going to go through every single item. The first thing I see is a 9. Now the 9 doesn't have any exponent. It's really an exponent of 1. It's not attached to the, each thing is its own individual factor. So the 9 I'm going to leave on top. Here's my fraction line. The next thing I see is an x to the negative 8. Since the x has a negative exponent, I know I have to take its reciprocal. It's in the numerator, it's on top, so it's going to have to go to the bottom, and it will become x to the 8th in the denominator. The next thing I see is a y to the 16th. Its exponent is positive, so I leave it where it is. In other words, I move something if its exponent is negative. I leave it where it is if the exponent is positive. This has taken care of the numerator. Now let's go to the denominator. Now in the denominator, the first thing I see is a 9. Well, that 9, again, has an exponent of 1, which is positive, so it stays where it is. The next thing I see is an x fourth. Its exponent is positive, so it stays on the bottom. Doesn't matter which you put first or second. And the next thing you see is a y to the negative 3. This has a negative exponent. It means you have to take its reciprocal. It's in the denominator. It has to be moved up to the numerator. So it becomes y to the 3rd in the numerator. And now we can do the final steps. First of all, dealing with the coefficients, there's a 9 on top and a 9 on the bottom. They can cancel out. Then we have in the numerator, we have a y16 and a y3. They're both the same letter, so we add their exponents. That's going to give me y to the 19th. And in the denominator, I have 2 x's, x8 and x4, so that gives me x to the 12th. Notice there was nothing else to cancel from top and to bottom because the top were all y's, the bottom were all x's. My final answer came out to y19, x12. So if you notice, I first removed the parentheses by if there was an exponent on the outside, distributing that exponent. Question? Have a question? Hello? The next thing we did was we looked at the exponents, and anything that had a negative exponent got moved, anything that had a positive exponent stayed where it was. Then you reduced any coefficients, any numbers in front, and then you combined the like letters. Are you ready to try one on your own? Okay, so I'm going to give
Yes.
I'm going to give you a couple to try while I take attendance. I'm gonna give you two problems to do. So this is 30. This is the first one. 30 x9 y negative 10 over 45 x9 y6. See if you could simplify that. And here's the second one I'd like you to do. X negative 3, y negative 5 square over x negative 4, y negative 3 to the fourth power. That's a little bit more of a challenge. Okay, while you're doing that, I'm taking attendance. Jesus Antonio. Jackson Avila. Tiffany. Okay, hi, Jackson. Tiffany here. Kayla Brantley. Kayla. Tashana. Hi, good morning. Dion. I know you're here, Dion.
Yes, I'm here.
Yes, I think we can count on you. That it's always good to have you here. Wensley Charlemagne. Tatiana Collins. Tatiana here. Awa Diallo. Hi. Yeah. Ashay Douglas. Hi. Eliana Este. Christopher Fleming. Emily Gomez. Hi, Emily. Anastasia. Zanabu. Ismail. I know you asked me a question, so I know you're here, Ismail.
Yeah, I'm here.
Yeah, hi. Jaden Jackson.
Here.
Hi, oh, good. I have you absent for a bunch of times. Is that true or you were here?
I was here.
You know what, do me a favor then.
Mhm.
just write me an email that you were here, whichever days you were. Because the last time I have you here is on September 23rd, and then I'll change it, but send me an email, okay?
All right.
Ashiana Jacobs. Ashiana? Hi. Anijah John? Thomas John?
Yeah.
Hi. Paul?
Here, morning.
Good morning. Ashley?
Here, good morning. I'm just gonna be changing from my phone to my computer real quick, okay? Just letting you know, because I can't really see the board,
Oh,
the questions, okay? It's kind of little on my phone. It's just because I'm on my phone. I'm
oh.
gonna change to my laptop. I'm sorry about that.
Even, I always check it on my tablet to see if I could see it, but I don't think I could see it on the phone. Angelica?
Here.
Hi, Angelica, and let me see, who did? Yeah, Tatiana, I called you, I'll change you. Tatiana Collins. Got you. Okay, we're up to Tayon Regist.
Here.
Hi. Akeem Phillip.
I'm here.
Good. Craig Ricketts. Giovanni Rowe. Giovanni. Devonley St. Jude. Hi. And Najee Waddell. Najee. Okay. Let me just mention, one day I'm just going to take attendance at the end of the period because I see people wait until I take attendance and then they stop watching. If you really know this stuff, then tell me ahead of time and I won't teach it and I'll just go on to new material. Okay, Akeem, thank you for giving us 2 answers. So let's do these together now. First of all, this one, as I said, the first thing we look for is a parentheses, but there are no parentheses. The second thing we look for, are there any 0 or negative exponents? And I see there is one negative exponent, this y to the -10. So that would make this 30x9 on top, 45x9, y6, and y10 in the bottom. In other words, we take this y to the -10 and we take the y to the -10 and just move it to the bottom. Now we can see if we can make this any simpler. So first of all, the 30 and the 45, let's just regular reducing of fractions. What's the largest number that goes into both 30 and 45? What's the largest common factor? Obviously, it's 15. So this is going to become a 2, and this is going to become a 3. 30 divided by 15 is 2, 45 divided by 15 is 3. Let's just put that here. So here's my 2 and my 3. The next thing I have is an x9 on top and an x9 on the bottom. Now, when you subtract 9 minus 9, you're getting 0. And you know, when you get a 0 exponent, that really means just the plain number 1. It doesn't mean x to the 1, it means plain 1. In other words, the x to the 9 cancels out with the x to the 9. If everything else cancels out and there's nothing else left there, you're going to have a 1. But since I have a 2 on the top and I have a lot of things on the bottom, I don't even have to put it on. If you have the exact same exponent on top and bottom, it just cancels out. Okay, that leaves us just the y6 and the y10 together in the denominator. Since they're both in the denominator, we want to multiply these two by adding their exponents. So we get y to the 16 in the denominator. So my final answer comes out to be 2 on top, 3y to the 16 on the bottom, which I see, Akeem, that's exactly what you got. Beautiful. Okay, is there any question about it? Again, you have to be very careful because it gets messy. And if you're not looking at it carefully, you can mess up whether something's on top or on bottom. Okay, let's look at the bottom one, the number 2. Now this one actually has parentheses as well. Now, if there was one parentheses around the whole exponent, over the whole fraction, then exponent on the outside, then I would use that exponent in both the top and the bottom. But in this case, we have one exponent for the numerator, there's an exponent of 2, and in the denominator, we have an exponent of 4. So the first thing we want to do is get rid of those parentheses by distributing that exponent. So first I'll do x to the negative 3 squared will give me x to the negative 6. Notice I'm not worrying about the positive or negative. I'm just worrying about getting rid of that parentheses. And the next thing is the negative 5 squared is going to give me y to the negative 10. I just multiply the exponents, the inner exponent by the outer exponent. In the denominator, I have an exponent of 4. So this will give me x to the negative 16. Because 4 times negative 4 is negative 16. And y to the negative 12. It turned out that every single one of the exponents were now negative. So what do we do now? Well, here's my fraction line. I'm now going to deal with the negative exponents. After I deal with my parentheses, I deal with exponents that are negative. X to the negative 6. It's on top. It has to go to the bottom and it becomes x to the 6 in the denominator. Y to the negative 10. It's got a negative exponent. It goes to the denominator. It becomes y to the 10. Then I look at the x to the negative 16 in the denominator. It's also a negative, so now this has to come on to the top. So I'm getting x to the 16 on the top. And the y to the negative 12, it also goes to the numerator as a y to the 12. So I take care of negative. Usually not all of them are negative, some are positive, I leave them where they are. The negative ones I move. And the last step is to look if there are any like letters in the numerator and the denominator. But here we have an x and a y. We don't have two x's like we did over here, where we had two y's in the same denominator. No, here this is x and this is y and this is also x and y. So there's nothing to combine that way. So now I try to reduce the like letters from the top and the bottom. So I have an x16 and an x6. I remember what I do. I cancel out the lower exponent, which is the 6. And I do 16 minus 6 is 10. So I get x to the 10 on the top, because that's where my larger exponent was. Then I go to the y's. Oh, really, I should just leave that line here. There's a y12 and a y10. The lower one is the y10. I cancel it out. 12 minus 10 is 2. That gives me y2. And the y2 is in the numerator as well, because that's where the higher exponent was. Since everything got canceled out from the denominator, I don't leave it blank. It really should be a 1. Since my whole denominator is 1, remember, you can only do this when the denominator is 1. You could leave your answer this way, but you don't have to put in a denominator of 1. So your final answer is x to the 10th y squared. If you're left with the 1 in the numerator, everything cancels out from the numerator and you're left with the 1 in the numerator, that you have to leave. 1 on top you have to leave. 1 on the bottom, you could write it as it's like 3 over 1 is just 3. But 1 over 3, you have to write the 1 over 3. So that's how you would do these examples. Very good. That was excellent. Okay. Okay, so I think we now know how to deal with fractions that are monomials. So what happens if my fraction is a polynomial? So how do we handle something like that? In other words, what if I were to give you something that looks like this? Y squared minus 5 pi minus 6 over y squared minus 1. Suppose I give you, we just learned how to deal with fractions that had with monomials and had exponents, etc. And we saw that we wanted to reduce our fraction. We wanted to cancel out the like factors from the numerator and the denominator. That's what we were doing here. But that was when we didn't have any pluses or minuses in between the letters and the numbers. If there was a sign, it was always in the front. Everything there was a single term. Everything was connected by the operation of multiplication. But in this particular fraction, we have a trinomial in the numerator. Notice we have this minus 5y and the minus 6. And in the denominator, we happen to have a binomial. We don't have monomials here. How do we deal when our numerators and denominators are polynomials? So here's the trick. We just spent a good part of last chapter learning how to factor. And we saw one of the uses of factoring was to solve quadratic equation. We're now going into another use of factoring. In order to reduce the fraction, you have to be able to cancel out like factors. It has to be the same factor. But don't think, for example, 6 is a factor here, or 1 is a factor here. A factor is something that's multiplied. But we know how to find factors. What we have to do is actually factor our numerator separately and our denominator separately, and then compare and see if we see any like factors. So to factor the numerator, remember the numerator happens to be a trinomial, so we use our AC method, and we know our AC is 1 times -6, which is -6, and our B is the -5. So we're looking for two numbers that when we multiply them will give us -6. Obviously, that means one is going to be positive and one is going to be negative. And when we combine them, our answer is going to be -5. So let's see what numbers multiply to -6. Well, obviously, it could be a +6 and a -1. Notice if I combine +6 and -1, what I get is 6 plus -1 is +5. I'm getting the right number, but I'm getting the wrong sign. So let's switch this. Let's make the 1 the positive and the 6 the negative. Put the negative in front so I don't have to. In other words, +1 and -6 do combine to -5. So this is my correct combination. I don't have to go any further. Rewriting that, that'll give me y squared plus 1y minus 6y minus 6. And now doing my grouping, this will give me y times y plus 1, because my common factor here is y. And here my common factor is -6. And that will also give me the y plus 1. So the numerator comes out to be y plus 1 as one factor and y minus 6 as the other factor, right? You don't have to write all this down. You could be doing this in your head, but the y squared minus 5y minus 6 factors into y plus 1 and y minus 6. Now let's look at our denominator. We have y squared minus 1. Now, remember when you have a binomial, again, you first look for a common factor, and there is no common factor. That's what you look for first. Then you see, since it's two terms, we know the only other way we can factor it is if this is the difference of squares. And this is y squared is y times y. 1 is 1 times 1. 1 is a perfect square, and there's a minus. So that can be factored to y plus 1 and y minus 1. Okay, so now we've done all the hard work. We've completely factored the numerator and the denominator. Notice there are two factors that are identical. What makes the factors identical is if they are exactly the same binomials with the same signs. It can't be a y plus 1. In other words, the y plus 1 can cancel out with the y plus 1. It cannot cancel out with the y minus 1. It has to be identical. So I cancel out the y plus 1 with the y plus 1. Again, if everything cancels out, we have to put a 1 in place of it. But not everything canceled out. We were left in the numerator with the y minus 6. And in the denominator, we were left with a y minus 1. Notice I didn't bother putting in the parentheses when you need those parentheses to separate them. Since there's nothing to separate, you can leave it without the parentheses. And this is your final answer. So let's go through the steps of this again. In order to reduce a fraction that has polynomials, what you have to do is factor your polynomials completely. And after they're completely factored, then you can cross out the like factors. The factors have to be identical. Here, let's see if we can do one. Together, one more together before the end of the period. Say, give you this example. Twenty y squared minus 45 is my numerator. My denominator is 10y squared minus 5y and minus 15. So we have a fraction that has a binomial on the top and a trinomial on the bottom. It's not a monomial over a monomial. In order to reduce this fraction, we're going to have to factor completely the numerator and the denominator. Okay, I'm going to give you a few minutes to try and factor it. Go ahead and factor both the numerator and the denominator. Okay, I think we should get started together because it looks like we're running out of time in any case. Again, I want to factor as much polynomials I have to factor. So first I look at the 20y squared minus 45. And I see there is a common factor. 5 goes into both 20 and 45. So I will have a 5 on the outside, and 5 into 20y squared is 4y squared. And 5 into 45 is 9. I can even go further with that because I see that now what's inside my parentheses is a binomial where the first term is a perfect square, it's 2y times 2y, and the second term is 3 times 3. So I can go even further and I can have 5 on the outside, 2y plus 3 in one parenthesis, and 2y minus 3 in the other parentheses. It's my difference of squares. Now I'm crossing these things out because this is what I want to look at. My numerator has become 5 times 2y plus 3 times 2y minus 3. Okay, now I'm going to the denominator. Try and do this neatly, because if you don't, you're gonna mess up just by not give yourself enough space so that you're not cramping things so close together that you can't see what your factors are. My denominator also happens to have a common factor of 5, because it's 10 and 5 and 15. Taking the 5 out, it'll give me 2y squared minus, I can just write it y minus y or minus 1y. I'm putting the 1 in to remind myself that it's a 1, and minus 3. Okay. Now, this is my trinomial. I want to see if I can use the AC method to factor this further. So if I'm using the AC method, I do 2 times -3, which is -6. That's my AC. And my B is my number that's in front of the Y, which is -1. And we're looking for numbers that multiply to -6. So again, one is going to be positive, one's going to be negative. It could be 1 and 6, but that's not going to be good, because when I combine a 1 and a -6, it'll give me -5. So the next combination I can think of is 2 and 3. And notice when I have a +2 and a -3, they combine to -1. So that's the combination I want. So this is becoming now 2y squared plus 2y minus 3y minus 3. And here in my first group, my common factor is 2y. So this becomes 2y times y plus 1. And in my second group, my common factor is -3. And that also becomes y plus 1. So this trinomial becomes y plus 1 times 2y minus 3. And let's bring down that with that 5 in front of it. Okay, so let's just cancel these all out. And I'm going to rewrite what I have here. When I have completely factored the numerator, I have a 5, a 2y plus 3, and a 2y minus 3. That's my numerator. In my denominator, I have a 5, a y plus 1, and a 2y minus 3. And now I'm going to try and cancel out like factors. Now the 5s are monomials, and actually they cancel out. The 5 cancels out with the 5. Even if this would have been, let's say, a 10, and this would have been a 5, I could have canceled it out. Then I have a 2y plus 3. But there's no 2y plus 3 in the denominators. When it comes to the binomials, they have to be identical. Now I have a 2y minus 3 on top and 1 on the bottom. That does cancel out. Again, if anything totally canceled out from the numerator or from the denominator, I'd have to put a 1 there, but not everything totally canceled out. I'm left in the numerator with 2y plus 3. And in the denominator, y plus 1. And this is my final simplified answer. These take some time to do, but if you notice how important it is to know how to factor. Okay, let me remind you again, this afternoon, probably after 2 o'clock, you will see the test 2 that you're going to be taking for this term. It's going to be on Blackboard. If you'll go to your Blackboard account, you'll see something called tests and quizzes. And in that section, you'll see it's the review for the midterm. It is a test. You have 20 questions. It's, again, as I told you, if you do better on the midterm than you do on this test, I'll just take as your midterm mark also your mark for your test 2. So we're going to have this test, you have to do it sometime before next Tuesday's class. You have a week to do it. The midterm itself will be next week. I don't know, it may be in class on Thursday, or it might be, I might give it to you as some sometime, again, give you a few days to do it. I'll have to ask if I'm allowed to do that. This practice midterm is due by next Tuesday. So you have, again, but once you sit down to do it, you must finish it in one session. Don't think you're going to do 2 questions and leave and then come back and do another 2 questions. It has to be done in one session. You get a total of 70 minutes in one session to complete it. But you have to finish it by next, I don't remember exactly what time I gave you, but by Tuesday's class next week. Again, next Tuesday, we will review if you have any questions. Yes. Dion.
By next Tuesday, will you be able to tell us whether or not we're going to be doing the departmental midterm online or in class?
Yeah,
Or,
I hope, if I don't, I hope to know by this coming Thursday, as soon as I have the information from the department. If they don't insist that I do it in class, I'm going to do it the way I've been doing all the tests. You do it at your leisure. But if they want it as
okay,
a
thank you.
class, then you're going to have to do it again. It's not going to be on. It's going to be on Blackboard. It's just a matter of whether it has to be a specific time or whether I can give you an extended time where you can do it at your leisure. Okay, and I will, as soon as I know that, I will email you. Any other questions?
Okay, thank you.
Okay, so have a good day. I'll see you on Thursday.
You
And
too. Have a great day, Professor.
We're going to be continuing with what we're doing today on Thursday, unless if you have any questions before, then you can certainly ask me, but have a good day. And as I said, we're continuing chapter 5 on Thursday. Next Tuesday, I will answer any questions on things that were on that practice midterm. Okay? Have a good day.
Thank you. Have a good day.